Hello friends, Jermaine here and welcome to today's package of the week. We'll be looking at the gRPC library and its Dart's implementation of the open source RPC framework. RPC is an alternative approach to client-server communication that involves invoking methods or procedures that have been defined on the server from the client. This has got great support for Dart server projects as well as Flutter projects. This also can be used in web-based projects as well. So in this video, we're just going to get ourselves set up and go through some examples. And without further ado, let's get into it. There are some prerequisites we need in order to get started with gRPC. Assuming you've got Dart already installed, we also need to install the protocol buffer compiler. This will take in proto buffer files that we're going to be writing and it will compile it to the relevant language. If you are on Mac, you can just do brew install protobuf and that will install the executable on your machine. Once we've got that, we need to install the relevant plugin for the platform we're targeting, in this case Dart. So just run this command to install the Dart plugin, which will be used by this protocol buffer compiler. Once that's installed, just make sure you've updated your path so the compiler will be able to find this plugin. So with the prerequisites out the way, this is the project that I have set up. It's available on the starter branch. If you go to the GitHub repo, I've got the gRPC package installed as well as the protobuf package. So this allows runtime support for protocol buffers. So once we've got these, run pubget to update your dependencies. So once those packages are installed, we are now ready to go. I have gone ahead and added db.dart under libsource, and this contains the data we're going to be working with. So this is a list of albums and we've got a list of photos. So the first step with protocol buffers is we need to define a structure that represents these two data structures we're going to be working with. So that brings us to Album.proto. This is an example of a file that uses the protocol buffer syntax. And over here, we've got what's known as a message. So a message allows us to represent different data structures, which normally takes in a list of key value pairs. Over here, we've got our album message, which has got an ID and title field. These fields correspond to the data over here in our albums list. So I've just got the ID and the title here. Each field is preceded by a type, and what we've got assigned is not the actual value for the field, it's a field number. So this is a unique identifier for the field, and we can assign any number from 1 to 15. And what this is used for is because these structures are going to be transferred over the wire in binary format. So the protocol buffer specification has specified these as a unique way of identifying these fields since they're going to be transferred over the wire in binary format. I've done the same here for photo, which also has got fields that correspond to this structure over here. So from this, what we need to do is to generate, using the protocol buffer compiler, some Dart data classes. The command we're going to run is protoc. We'll specify the Dart out option. So this is where the final generator code is going to land. And then here we pass in the iProtos flag. This just allows us to specify the proto file we want to generate from. Okay, let me run this. And when we look over here, we see a couple of files that have been created. This first file contains data classes that have been created based on our definitions here. So we got album, and then in here it's got some factory constructors as well as some other methods. And there's also one for photo, which has got the same sort of methods here. And also is aware of each of our fields that we've defined. We've got other files. So this one, there's nothing in there because we're not using enums. And there's also this file here that has got a JSON-like representation of the fields of our messages structure. Based on what we've generated, we should be able to, in fact, work with that. I'll come to gRPC demo.dart. I'll get rid of this, and we're going to export our database as well as our generated files. And then in bin gRPC demo, I'll get rid of this alias. I'll delete this. I'll go ahead and create an album, and then I'll specify the fields, and I'll print this out as such. Let's go ahead and run this. Okay, and that gives us that. You can also use some of the factory constructors that have been generated. So let's do album from JSON, and in here we'll pass in a JSON string. The key of the JSON string will be the unique field IDs we specified when we created the album message. So this would be the unique field number for our ID. And then in here, I will use the albums data structure. So we'll use that. I'll get the first item, and then I'll output the ID. And then for the title, the first album title. And I'll just print this out. Okay, so that gives us that. We can go ahead and invoke some of the helper methods that come with this. So we can call clone, for instance. We can create a copy and then update the fields in our copy. We can also write to various formats, so including JSON and a JSON map. So let's do JSON for now. And then let's run this again. And then we get all of that. So this is our clone, our copy with the update made, and then our JSON output. So what we've looked at pretty much is the protocol buffers part. So where gRPC comes in is the fact that we are able to define RPC services in our protocol buffer file. I'm going to create a service here. We'll call it the album service. This service allows us to create a definition for procedures that we're going to be invoking. So this is our service method, and we'll define one called getAlbums. This method takes in a message. I'll call it album request. This will return an album response and just end it with a semicolon, or you can just end it with an opening, closing, curly bracket pair. Either works. So now I'll go ahead and create the messages for album request and album response. Album request will take in an ID field, and then our album response will take in a list of albums. And to represent a list in the protocol buffer language, we just need to specify the repeated keyword. So now let's go ahead and run our compiler again, which will generate the relevant service classes for us. So running the command creates this new file. Then in here, we've got a service client generated for us, and then a service base, which means we're now able to create a gRPC server with an associated client. So let's go and do that now. I'll go ahead and create a server.dart file in the bin folder. I'll import the gRPC library as well as gRPC demo. I'll start by creating a class called AlbumService. This will extend AlbumService base, which is from this generated file. In fact, I can copy this, and in gRPC demo, I'll export it as such, which means I can get rid of that. And right now we are told that we are missing a concrete implementation of our getAlbums service method that we defined over here. So let's go ahead and add it. Okay, in here we just want to, for now, return an album response. And let's mark this as a sync, and we are going to add some items to our albums list. But before we do that, let's create those items. I'll create an album list variable, and then I'll loop over the list of albums we got, which again looks like that. We'll map over that, and we are going to return an album object. We'll specify our JSON format as such, and then we'll convert into a list, which means that we are able to pass this in here. Next, we just need to create our server that uses this service. I'll create a main function. We'll create our gRPC server, which takes in a list of services, and we just need to instantiate album service. Next, we need to serve the server on a port. And let's just print out a message when it's ready. Okay, so let's run this. We've got our server running. Next, we need to create the client to connect to the server that we've just created. So on the bin, I'll create a new file. I'll call it client.dart. I'll create a main function. we'll start by creating a client channel object, which contains details about the server we are trying to connect to. This server is on localhost and it's on port 5000. Then we'll set some options, and the credentials here we'll just say it's insecure because we are doing this over HTTP, not HTTPS. And in order to make the actual call, we need to create what's known as a stub. So a stub is gRPC's client or HTTP client, but in gRPC lingo, I guess it's referred to as a stub. And in here, we'll create an AlbumService client. So this is the auto-generated class, and it receives our channel. So from this now, we are able to make our call to our gRPC server, and we'll await on stub, and straight away we see that we get access to our getAlbumsService method, and we need to pass in our request object, which was album request. For now, we'll not specify the ID, and let's print out the response. Okay, let's go ahead and run this client and see what we get. Okay, so we got this response, which is a list of albums here. And if you notice, the process is still running because we need to manually end the connection by invoking the shutdown method on our client channel. So I'll kill this and run it again. Okay, it's ended. And the reason why it looks like that is due to the implementation of the toString method that has been overwritten. But we can do this instead, write to JSON. And if I run that, that'll give us this JSON object. And if I go ahead and format this, it gives us this as an output. So it's a list of albums, and each key is based on the field's unique number that we specify. So this would be the ID, and this would be the title, etc. And this corresponds to the unique ID that we set for the album's field name in the album response message structure. So this one. So we got some data coming back. Let's go ahead and do a bit more to this. So we can invoke getAlbums again, but this time we'll specify an album ID. We'll print out the response, and I'm not going to run this because we need to modify our method on the server side in order to take this part in. Let's come to server.dart, and then in here, we are able to pick up the ID from our album request object. So I can do if request.id greater than 0, which is because if I come back to this proto file, each of these fields are given a default value. So for integer fields, the default value is 0. For string fields, the default value is an empty string. And for lists, it's an empty list, which is why I'm making a check that is greater than 0, because if it's 0, then that means it's the default, it's not been set. But if it's greater than 0, that means we've set an ID from the client. So if it's greater than 0, what we want to do is to create an album variable, and we'll loop over our albums. And we want an album where the album ID matches the request ID. And once we found that, we'll map over the results as such. So same logic here, and then we'll convert the result to a list. And then from that, we'll return an album response. And then for our list of albums, we'll add this album that's been found. So this will give us a response containing a list of exactly one album, the album which was found. So let's test this out. I'll save that. I'll kill the server and run it again. So let's run this again. All right. So in our response, we have exactly one result, which is because we specified it here. Let's come back to our server, and then let's refactor this a bit. I'll create a couple of helper functions. One is called find albums, and this will basically do this bit. And here we just want ID. I can invoke that function here and pass the request ID. And in fact, I'll go ahead and create another helper function. We'll call it convert to album, which will take in our album map object, and then it'll convert it to an album object. So this bit here, we'll have that here as such. And then I'll copy this, and I'll have that here, and I'll have that here as well. So let's save this. Okay, this looks much cleaner. Let's run our server again and ensure that it works. Okay, everything still works fine. Let's go ahead and create another service method. I'll come back to our album protocol buffer file, and we'll create our second AlbumService method. I'll call it getAlbumsWithPhotos, which takes in an album request and then returns an album response. What I'm thinking of doing with this is, if we come back to our data store, each of these photos have got an associated album ID, and the IDs correspond to these IDs here. So I'm going to come to album, and then I'll define a repeated field. This will contain a list of photos, and I'll call it photos, and we'll give it a unique field ID of 3. And we need to go ahead and run the generator. This means we need to come to our server and implement our method. I'll mark this as async. I'll return an album response. And then for our albums list, we'll add all. And in here, we'll map over our albums. We'll convert the map structure to an album. And then we'll find the photos related to the particular album. So I'm going to come ahead and create another helper function, and we've called it find photos, which takes in an album ID. We'll go over our photos list, and we want to find where each photo's album ID is equal to the ID we pass in. We'll map over the results, and in here we want to convert the results to a photo object. And then once we're done, we'll return a list. We need to implement convert to photo, similar to what we've done here. We will invoke the from.json method. For the album ID, we'll just output the photos album ID. For the ID, for the title, and for the URL, we'll have the photo URL. So I'll save that, and we'll come back over here. For our album photos, we want to do find photos. We'll pass in the album ID, and we just want to return our album object. And for the photos, we'll add the photos we filtered. So let's kill this server, run it again. I'll come to the client, and let's make another procedure call whereby we're getting the albums with photos. We'll create an album request object. We'll set the ID. Let's print out the response, and let me comment this bit. Let's run this. And I forgot to close this bit. My mistake. Let me kill this server and run it again. And I'll go ahead and run this client. Okay, so we got our response. For this album, it contains these photos. For album with an ID of 2, we only get 1 photo for it, and so on and so forth. Let's go ahead and filter out the album based on the request ID we specify. We'll do the same as the previous one. We'll filter out the album, and we'll filter out the album photos. Then from that, we can return our album response, where we are going to add to our albums list. And to make this easier, I'll just move this over here, such, so we can do album. And then for our photos, we'll add all of our filtered album photos. Let me stop and start the server again. And then I'll run our client, and that should just give us the album we asked for. Okay, let's log out the actual album. We can invoke write to JSON, and also can write it out as a JSON map. And let's run the client again. And here's our JSON object, and this is our JSON map. So if I take this JSON object and format it, it gives us that. Okay, so far we've looked at one of 4 different styles of communication between a client and server within the gRPC architecture. This is described as the Unary style of communication. So a client makes a request, and then server sends a response, and then we end it there. However, I'm going to cover another style, which uses the streaming interface. So this will be a request sent from the client to the server, and then our gRPC server will return a stream of responses. So to demonstrate that, I'll create another RPC method. I'll call it getPhotos. This also accepts an album request. However, it returns a stream of photo messages. There's also one where it's bidirectional, so the server will return a stream, as well as the client also sending streaming interface. There's also the 4th style where the client is stream based, but the server is not. However, in this example, we're gonna do this instead. So the server will send down a stream of responses, and then we'll handle it on the client. Okay, so let me save that, and then I will run my generator. let's go to our server.dart file and implement our getPhotos method. I'll mark this slightly differently with the async star syntax. So we're going to be using the generators feature of the Dart language to work with this stream because it's easier to read in my view. I will start by creating a photo list variable containing my list of photos, and we'll just loop over that. To add data to the stream, we are going to yield followed by the data we're going to add to the stream. So we'll say photo from JSON. I'll use a multi-line string to create our JSON object. And then for each of our fields, we'll have something similar to this one here. So I'll just copy that and paste it in here. I'll get rid of the curly braces and let's do that. Also make sure you don't have a trailing comma at the end or else you get a format exception. So I'll save that. Then let's restart this server. I'll come to the client and I'll go ahead and create a variable called photostream. We do stub dot and we'll invoke getPhotos, pass in our album request, and we'll use the await for syntax for looping over the stream. And for each photo in our photo stream, we are going to print out a message, and then each message will have the photo URL. Let's test this out. Okay, so there we go. All right, so next let's make this specific to an album ID. We'll have our if block, and then we'll set our photo list to be specific, and then we'll convert it to list, and everything else should remain the same. So I'll save this. I'll come back to client. Let's invoke the getPhotos procedure. I'll specify an ID this time. I'll use the await for loop. I'll print out the result and we'll print out the photo URL. Let's check this out. Oops, let me restart the server and then run the client. Okay, so we've got exactly 3 photos that have been filtered out, because if we look at our data store, we've got exactly 3 photos with the album ID of 3. And this brings me to the end of the video. If you found this helpful, smash that like button and share this video as well. If you are not a subscriber, hit the subscribe button and hit the bell notification icon so you don't miss out on any updates. If you've got any questions on this or you want me to make more videos on this, do let me know down in the comments below, and I'll see you in the next video. Thank you.